Hello, I am Abhinav Sharma. Welcome to Python Wife.
Now let us learn about asymptotic notation. When it comes to analyzing the complexity of an algorithm in terms of time and space, we can never provide an exact number to define the time required and the space required by the algorithm. Instead, we express it using some standard notation called asymptotic notation. Now, when we analyze any algorithm, we generally get formula to represent amount of time required for execution or the time required by the computer to run the lines of code of that algorithm, or the number of memory access, or the number of comparisons, temporary variables which are occupying the memory spaces. Now let us take an example. So here in this example, there is a equation T of n is equals to n square plus 3n plus 4. It is a quadratic equation. Now for larger values of n, 3n plus 4 will become insignificant in compared to n square, right? For example, if n becomes 1000, n square will become way more than 10 lakh, right? So while 3n plus 4 with the value of 1000 will become 3004. So in front of 10 lakhs, what will be the value, or how can we compare 3004? It is an insignificant comparison. Also, when we compare the execution times of the two algorithm, the constant coefficient, you can see here, n square will go exponentially, and the constant coefficient here you can see is neglected. An algorithm which takes time of 200 ki power n square will be faster than some other algorithms that take n cube for any value of n which is larger than 200. But we are interested in asymptotic behavior. Now, what is asymptotic behavior? The word asymptotic means approaching a value or curve arbitrarily. So if you remember, we have a chapter called limits in our school. The only difference being here, we do not have to find the value of any expression where n is approaching any finite number or infinite. But in case of asymptotic notation, we use the same model to ignore the constant factors and insignificant parts. Now let us look into the types of asymptotic notation. Generally, there are three types of asymptotic notations which are used to represent the growth of any algorithm as input increases: big theta, big O, and big omega. When we say tight bounds, we mean that the time complexity represented. Uh, okay, so this is the graphical representation of big theta. It is also called as tight bounds. Uh, when we say the tight bounds, we generally means that the time complexity represented by the big theta notation is like the average value or the range within which the actual time of execution of the algorithm will be. So here you can see a graph, and this graph having a range of C1, G, function of G is a function of n. So C1 to C2 is a boundation or a tight bound, and function n will lie between these two extreme values. For example, if we have an equation 3n square plus 5n, then n square will be the complexity, and we will ignore all the constants from those complexity. Now let us understand about upper bounds, which is big O. This notation is known as the upper bound, and we use it a lot in founding the worst and best case complexities of various algorithms. We will talk about big O more in the later videos, but in general, it tells us that a certain function will never exceed a specified time, or space for any value of input n. So here you can see there's a function n and there's a upper bound c g of n. So f of n will never going to exceed this c g of n at any specified value at input n. Now the third representation is the omega. Big omega notation is used to define the lower bounds of any algorithm, or we can say the best case of any algorithm. Lower bound, you can see cg of n is below the function n, which means function n will never go beyond cg of n. In simple words, when we represent a time complexity for any algorithm in the form of big omega, we mean that the algorithm will take at least this much time to complete its execution. Now, it can definitely take more than this too.
Thank you for watching. For more such videos and detailed explanation, visit pythonwife.com.